Hi, Alan Stratton from As Wood Turns. Well, at the AAW Symposium in Raleigh this summer, one of the presenters that I appreciated was Max Brosi from Ireland. And I've tried to mimic some of his forms so that I could incorporate it into my repertoire. He did a lot of multi-axis work, and this mimics one of his. It's a tad smaller, but it is an interesting form. I think it's worth doing, and so let's turn this very interesting little multi-dimensional form. This wood is ornamental pear, very wet and fresh from a neighbor's tree. Previously, I rough turned and waxed the spindle. Now I've remounted it into the original marks. I'm trimming one end to get a straight end and to clean off the wax. The spindle is long enough that I don't have to worry about the other end. Now to measure the diameter and calculate the key points for an octagon. Remember, the diameter times 0.293 is the distance from the end to a corner. The diameter times 0.414 is the length of a side. Then transfer the marks to the spindle. I've also marked the size of a side on the right side of the spindle. For the left side, there's a lot of wood in the way. I'm first using a gouge and then a skew with a peeling cut to reduce the wood to a diameter equal to the side of my octagon. It gets pretty deep, so I switch to a parting tool. Then cut back the top and bottom corners from the corner marks to the mark on the right end and the diameter on the left end. This is a 45-degree angle cut. Then divide each side in half, then in half again. I reduce the left end smaller and guess at the marks. Then proceed to round off the octagon into a sphere. I don't need it perfect, only pretty close. Eyeball is close enough here. My lathe does not have its own indexing feature. I decide to cut a tenon on the waist side of the spindle to fit a chuck. Then I can use the indexing on the chuck. Once mounted to the chuck, I can use the indexing marks on the chuck by using a point through a piece of wood on top of the lathe bed. I need 4 marks 90 degrees apart. I decided to drill 1.75-inch holes for this project and use a 2.25-inch tenon. My drill chuck will fit in a 1.75-inch hole, enabling me to drill deeper than my drill bit. But I might not need that depth this time. So I'm measuring for a 2.25-inch tenon on both the right and left ends. I'm not marking it with the lathe running. I make a mark, test it, then adjust again as needed. After cutting these tenons with my skew, I can part off the sphere. Now I can mount the sphere directly to the chuck, preparing to drill the 1.75-inch hole from both ends, switching around the mount before the final drill action. Then remove the chuck and replace the drive and live centers. After taking a moment to center punch the lines at 90 degrees, I'm mounting the sphere again between 2 of the marks. The center punches certainly help to mount it correctly. Then, just as I did a bit ago, I mark the 2.25-inch tenons and cut at that mark to make a flat. Then remove about a 1/4 inch and cut the tenon. Both sides of the sphere get this treatment. Now to remount the chuck and remount the wood into these new tenons. Just as I did before, drill the same size hole, reverse, and drill the opposite side. Again, I switch back to the drive and live centers. Again, mark for the tenons, cut the flat, cut the tenon, and repeat for the opposite side. Just as I did before, I'm remounting the chuck, remounting the wood to the chuck with the new tenons and drilling the opposite sides. Now, that was not so hard. I have to take a short break to make some utility plugs out of scrap wood. These need a tenon to fit inside the 1.75-inch hole. The outer perimeter will be the size of the tenon, or 2.25 inches. To make these, I press the wood against a closed chuck with the live center pressure while I'm cutting. At the very end, I reverse the wood into the chuck so that I can mark the center. I'll need that later. Now for the fun work again. I'm mounting the sphere by inserting plugs in opposite holes between centers. This is a bit tricky, so I'm being cautious to sneak up on the cuts. I first cut about halfway between the two corners. Then rotate the sphere to a new set of opposing holes and make a similar cut. Then rotate the sphere to the final set of opposing holes to make the cut. I was too cautious, so I'll need to go through that all again, cutting closer to the now vertical tenon, but not into it. Success! I now have a basic octahedron. I could stop here, as that is where the demo I saw stopped. Max did not want to do the carving in that demo. To start the final shaping, I'm using my right angle tool with a rasp cutter, but I have a tough time doing much with it. With its size, I have a hard time doing much shaping. I'm having better luck with a RAM system icon cutter. I try a couple of different cutters and end up with a cone cutter. I work around the wood using the lathe as a holder. I find it convenient to flip the wood to work the other side. This works better than twisting myself around. I switch to a new set of holes and repeat. Actually, I keep at this until I'm happy with the result. My fingers are the best gauge of wall thickness as long as I keep them away from the cutter. After multiple rotations, I went over the wood with 120 grit by hand to smooth out the corners. I bleached this wood in a separate video. Now I have an octahedron form similar to Max Brosi's. This is a basic multi-axis form that gives a foundation for many similar forms. Now that I've completed one, this form does not intimidate. I rather like it, and now I can do much more. Please give this video a thumbs up, subscribe on my website, tell your friends, and send me your comments and questions. Every week I make a new woodturning video. Please wear your full face shield anytime the lathe is running. Until next week's video, this is Alan Stratton from As Wood Turns.